Hey coding birds, so basically in today's GFG POTD we have a problem sum of nodes in binary search tree range, and it is a medium level problem. And as the problem statement is given the root of binary search tree and two integers left and right. The task is to find the sum of all nodes that lies between L and R, including both L and R. Okay, so here we have an input value which is like 22, 12, 30 and 820, and here we have a range, like we can say that L as left and R as right. So here we have ranges 10 and 22, and we have to include both L and R ranges. Okay, so if we have to like make sum of nodes, then what we will get if we actually going to do inside this root. So here we will get like 12, 20 and 22 which lying in this range, and the sum of it is like 54. So here our output will be like 54. And talking about my second example here, so here we have 8, 5, 11, 3, 6 null and 20 value, and here the ranges is like 11 to 15. So if we like make sum of it, so here we can set only 11 values like present inside this range. So here we can't able to do like any sum with any other nodes, so here we have to just return only this value. Okay, so here constant is given number of nodes must be like greater than equal to 0 and less than equal to 10 to the power 4. Node should be like greater than equal to 0, and here nodes data is like greater than equal to 0 and less than equal to 10 to the power 4. And here we have to solve this problem with an expected time complexity of order of n and expected auxiliary space of order of n. And here topic text is like binary search tree, data structures and algorithms. So let's try to solve this problem. So first of all, we have to like do check about the base case. So here I can check about the base case. Let's say if I'm saying that if my root is equal to null, that means if there's no any node, then here it is simply return 0. Okay, as we can't able to perform any sum of any other nodes. Now after that we have to like perform some operations like first of all we have to check for this range left and right. Okay, so here we can check if root data is like, we can set it greater than or equal to, because we have to also include the left ranges. Okay, and root right is less than equal to right ranges. Then inside that we have to first of all declare a result key, a result variable where we have to store our final sum of all the nodes. So here we can set result is equal to 0, and inside that we can simply do result plus equal to here we have to simply do our roots data. Okay, because here we have to take here we actually checking for both values. Okay, like inside the ranges which are like greater than L and less than equal to R. Okay, so we have to take the sum of it of that node. Okay, similarly we have to check for another conditions, like here we can say that if root data is like greater than left value, then here we can simply say that, or left range, here we just simply say that result plus is equal to, which is shorthand summation, and here we have to just perform the recursion. Okay, as you know very well about recursion, when a function is calling itself again and again, then it is called recursion. So here we have to say that node sum, and here we have to take our left's data. So here we can say that root left, and here to just simply provide our ranges L and R, and at the last we have to provide one more condition, which is we can say that root data, if it is like less than R, which is my right ranges, then again we have to just simply do result plus equal to, again perform the recursion for the right node. Okay, so here we can say root right, and then we have to provide the ranges. Once we have done these things, then we have to just simply return our result. Let's try to compile and run. Okay, so here I've done some mistake here. Okay, roots data, root right. Okay, so here to write roots data. Okay, because here we check inside the right ranges. Let's try to compile and run again. So its compilation is completed. Let's try to submit it. So yeah, it's submitted. So that's all for today. Thanks for watching.